Okay, so what we're going to be doing today is practicing how to find the epicenter of the earthquake. So for this demonstration, I'm going to go over the first example in your labs. So the things that you're going to need today are your lab. You're going to go to the last page of your lab and rip off your seismic data for 3 different locations. For this demonstration, you're also going to need your safety compass, a pencil, a scrap piece of paper, and your reference table. This is page 11 of your Earth Science reference table. At any point in this video, you might have to stop and do the task and then kind of move on once you're done doing whatever you need to do. So the first thing we're going to do is we're going to look at our seismic data for each location. You'll notice that there are these wavy lines here, and what these wavy lines represent are the arrival of a P wave and an S wave at a specific location. P waves and S waves are those forces, those waves that are going to be given off by earthquakes as they go off, and we can use the difference in arrival times to find the distance to the epicenter of the earthquake. So what we do is, first thing, we take our scrap piece of paper and we find the arrival time of the P wave and the S wave. So you have your time down here, and you want to make sure you get an accurate time. And to do that, you put your piece of paper right on that P wave, and we see that this arrived at 231, 232, 233. So I'm going to write on my piece of paper, P wave, 233. And actually, I'm going to put a 0 in front of that and 2 zeros behind it. This represents seconds, minutes, hours. So the second thing I have to do is find my S wave arrival time. By the way, we're working for the location in Chicago right now. My S wave arrival time is going to be 2:35 and 10, 20, 30 seconds. 0, 2, 3, 5, and 10, 20, 30. Okay, so now we have our arrival time of the P wave and the S wave. If you need to stop the video for a second, do that now. Our next objective is to find the difference in arrival time between the P wave and the S wave. And in order to do that, I need to list the S wave first. So I'm going to say 2, 35, 30 for my S wave. And from there, I'm going to subtract from it my P wave. We list the S wave first because it takes longer to get to the seismic station because it travels slower than the P wave. So now I'm going to subtract these 2 times. So 30 minus 0 is 30. 35 minus 33 is 2. And then 2 minus 2 is 0. So I have a difference in arrival time of 2 minutes, 30 seconds. I can then go here to my lab and copy down the information for my P wave, my S wave, and my difference in arrival time. Just to save time, I'm not going to do that right now. I think you can make that jump. The next thing we're going to have to do is find the distance to the epicenter in kilometers. So in order to do that, I'm going to go to my reference table, page 11, and the first thing I'm going to do is I'm going to use this difference in arrival time to try to find the distance. So what I'm going to do is I'm going to line up my paper on the the vertical axis over here. And notice that all of these are minutes, time in minutes. They go up in increments of 1, but the lines in between are actually 20 seconds. So if I look at here, this is 2 minutes, 2 minutes 20, 2 minutes 40, 3 minutes. So I'm trying to get 2 minutes, 30 seconds. I'm going to put my paper flush like this with that vertical axis, and I'm going to mark with a thin line 0, and I'm going to mark with a thin line 2 minutes, 30 seconds. Now, there's not a 30-second mark on this number line. So you're going to have to go right in between 2 minutes and 20 and 2 minutes and 40 seconds. The next thing I do is I take this piece of paper and I line it up in the upper right-hand corner so that my paper is flush with these vertical lines. And what I'm going to do is I'm going to move this piece of paper down until both of my lines touch both the P wave and the S wave line. So I'm going to go down, go down, go down, keeping this straight the entire time. And I'm going to see that right here is where this 2 minute 30 line touches my S wave, and this 0 touches my P wave. And if I hold my piece of paper there and I go down, I can see that now I'm at a distance of 1,600 kilometers from the epicenter. So I'm going to write that right here, 1,600 kilometers. I'm going to go back to my lab and I'm going to transfer the data on to here. Now, if you need to stop and rewind at this point, go ahead and do so. I'm going to go on to the next step. So after I have my distance to the epicenter, the next thing I need to do is actually plot on my map where this is. So since this is the data for Chicago, I'm going to make a radius around Chicago that is 1,600 kilometers. So to do that, I go to my map in my lab, and I see that Chicago is right here, exactly where it should be. And in order to do this, I'm going to use my safety compass. Now, a couple important things. Number one, you're going to want to start with the 0 on this little kind of clear button thing right here. So first thing I'm going to do is I'm going to line up that clear button with 0. The next thing I'm going to do is I'm going to pick this hole right here, and I'm going to move it until it lines up with 1,600 kilometers. So I'm going to go right there till it's on exactly 1,600. If you need to, kind of move this out of the way and look and see how much these are going up by. In this case, they're going up by 100. Here's 1,000. Here's 1,500, and then there's 1,600 right there. And I got the hole for that right on 1,600. Now, after I do that, these things move around very easily. I'm just going to kind of take my hands off, move my 0 marker up to Chicago, and put a finger firmly on there. Being very careful to use the same hole that I lined up 1,600 kilometers with. I'm going to draw a radius around Chicago. Like that. So now what does this mean? Well, we have a seismic station in Chicago. We got information from an earthquake, P waves and S waves, and using the difference in arrival time, we established that it's somewhere 1,600 kilometers away from Chicago. Now, at this point, it could be anywhere on this line. What you're going to need to do is get the data for the next 2 cities and make circles around them. Once you do that, all these circles should touch in one place. Now, they might make a little triangle. That's okay. You're just going to color in the triangle or put an X or whatever the procedures tell you to do. So again, if you needed to kind of go back to this video, rewind, look at some of these things again, you can do so. I'm going to go on to show you one last thing. On your lab, there's also these things, these columns that you need to fill out where it says P wave travel time and time of origin. So this is basically how long it took the P wave to travel from the epicenter to the seismic station. And this is the time that the earthquake actually happened. So here's how we do this. We know, for instance, that Chicago, the distance to the epicenter is 1,600 kilometers. So we're going to use that to find the P wave travel time. I'm going to take my piece of paper and I'm going to go to my reference table. And I'm going to go start with the distance because we know that. The distance is 1,600 in this case. And I'm going to go to 1,600 and go all the way up until it touches the P wave. When I do that, I can see that the P wave traveled for 3 minutes and 20 seconds. So again, I'm using the distance of 1,600 kilometers until I come up and it touches the P wave. And I go over until I see that it took 3 minutes and 20 seconds to arrive. I'm just going to write it down on my piece of paper for now. P wave travel equals 3 minutes, 20 seconds. So it took 3 minutes and 20 seconds to get there. We know that the P wave arrived at our travel station or at our seismic station at 2:33:00. So in order to get my origin time, I take 2:33:00 and I subtract my travel time, and that will give me the time of origin of the earthquake. So I hope this helps you out. Again, rewind if you need to, and good luck.